Thank you, Lisa. Thank you, everyone, for attending this talk. I know you had options, so you decided to come here. And for you guys online, whether you're all dressed or in your underwear, you decided to log in. So thank you, everyone, for attending. My name is Rayed. I'm Partner Solutions Architect with MongoDB. But I like to define myself as an application developer. I've been building application for the past 8 years. I really enjoy building applications that solve real-world problems. And that's what the purpose of any developer. But now, so many things have changed, especially in the past few years with the arrival of AI, but it was not the first time we had a shift in technology, a shift in the world that generated this type of disturbance. I wanted to first introduce you to the concept of the product lifecycle. Whether we're talking about the Big Mac or an application in banks, is the same thing. Everything is subject to the product lifecycle. It's a concept that has been coined by Theodore Levitt in the 1960s, which designs the lifetime of any product between the time it hits the market until it's taken off the shelf. And all applications that we built are subject to this product lifecycle. And this is why we see applications that we call now legacy, meaning they are at the latest stage of their life and they're just surviving until they are decommissioned and they are replaced by some new apps. So why, when we're building application, does it become obsolete? Why does it turn to die at some point? Why can't we just post some code, it's static, we deploy that, we let it run, it should be working forever, right? Why it's not like that? Well, ask people who built apps who had dependencies with Log4j. Your environment is always moving. There will be some vulnerabilities coming up. There will be some shifts in paradigm, some new technologies that are available that force you to change the application. It cannot just sit here and live forever. So this type of evolution drives what we call software rot. The software is a living organism that depends on its ecosystem. And if it's left unused, if it's left unmaintained, it rots like a fruit in your fridge. So what are the components that make the ecosystem change? We've seen multiple steps that drove changes. First is the arrival of the cloud and smartphones. We now are used to having within our fingertips and be connected online 24/7. This drove new businesses, a new way of consuming. When we now order our food online, we order our cab online, and we don't want to call someone and speak to someone. We want whatever we want it now. Amazon has launched the Prime Now offer where they can deliver within 24 hours. Even in some places, they can deliver within 4 hours. There's the DoorDashes, the Uber Eats, all those type of services that now create new expectations for customer. And of course, fast forward to 2023, ChatGPT launched to the public, and it really changed the perception of what a smart application is. And now, as an application developer, we all are under this pressure of delivering an experience that's much smarter than what was expected 3 years ago. What's in the future, we don't know. It could be smart robotics, it could be Web3, but the only thing we know for sure is like taxes. We know that the technology will be advancing and there will be need for change. And that change, the fact that you need to change, will impact your code base. And your code base basically consists of 2 levels of complexity. The essential complexity, which is related to the problem you're trying to solve. If you're trying to build a tax report app, you need to understand the legal around taxes. That's the essential complexity of your app. But then there's the accidental complexity, which comes from the decision you make as developers. So what choice of language, what choice of architecture, what choice of database, all your decisions that you make drive accidental complexity. That's why you try to delay any committing decision as much as possible. In the accidental complexity world, there's a subset of it that's called data complexity, especially when your application scales. When we look at the data volume that enterprises create and consume, the total data volume of data collected has been growing exponentially, and it has been for quite some time. But if you look at the right-hand side chart, this is a representation of the Moore's law. The Moore's law, I'm sure you're all familiar with it, is the fact that every 18 months, you could double your CPU power for the same price. So no problem, more data, more CPU. I just throw a bigger machine at the problem and it works. No need to work on anything. This was true until the mid-2000s. Then we start to see a small decline in terms of the CPU power available per dollar, which means that now you cannot just keep doing more of the same and throw more power at a problem. You need to find alternative options. And this is the timing where NoSQL databases start to see the light of day, the mid-2000s. Of course, as the years went by, you see that this is even less true. And now all those products need to find alternative and complementary products, data product, to solve your data problem. So now, instead of having one relational database to solve all of your issues, you need to have your main database, you need to have other NoSQL products, a search engine, a time series database, you need to have lots of products, and now in the world with AI, you need to have vector search to do that. And that complexity, that infrastructure complexity, really adds a lot of burden as a developer. So traditionally, you would start any application, plug in a relational database, design your data, and normalize your data around it, and that would solve 90% of your use cases. Once you hit some specific limits, you go add a caching layer, key value store, because you have slow running queries and you need to be able to perform those faster. You might have a need for a search, whether it's semantic search, and now with GenAI you need to do some vector search in your application. So you go add Elasticsearch to your stack. And you might have another feature, which is a recommendation engine. You try to do that with relational, you get hit with the N+1 query problem, and you go try to find another niche database, like a graph database, to solve that specific problem. And you end up with having 4 or 5 pieces of technology that you need to set up the infrastructure, monitor that infrastructure, connect your code to it, so write code to move that data along, and write the tests to go against that code. And that plumbing can easily lead you to over 50% of your time just doing that plumbing and debugging why is your data not being replicated from point A to point B instead of delivering more features. So getting to an infrastructure like this with so many products is good for your resume because you now get to say that you've worked with so many pieces of technology. But in practice, as you're building your application, it really hits your velocity. And velocity is what makes a team be able to deliver the right product to the market and keep it alive for as long as possible. So what is the value of NoSQL and what made it see the light of day? NoSQL database, like I said, saw the light starting in the mid-2000s. And if you see this quote from Martin Fowler, for those of you who don't know who Martin Fowler is very, very well-known, a very respected architect. And he said that it brings 2 key benefits. First of all, it improves developer productivity because we get closer to how developers work with objects in their code, in object-oriented programming. The second key benefit is that it helps you handle a large volume of data much more effectively with their horizontal scaling capabilities. But he also said in 2012 that applications should wait. If they're not critical, they should wait until the ecosystem gets much more mature in order to move their workload to NoSQL databases. Fast forward to 2024, MongoDB and the rest of the ecosystem, we've all matured, and now most of NoSQL database are mature enough to take any kind of production workload. So in the perspective of application development, there always have been three domains that were connected but pretty separated. The past few years, we had infrastructure versus software engineering. Developers would produce their code, send it to the ops team and say, okay, my code's working locally, you deploy it, that's your problem. Same thing with data. Application would just pour their data to some data lake or data warehouse, and the data team was responsible for receiving it, sorting it, trying to make sense out of it. But as the practice and the best practice of software engineering evolved, all those domains were moving closer together. Now, it doesn't mean that a software engineer should be capable to do the job of a data engineer or of an ops engineer as well as he does, but we all need to do a little bit of everything. So as a developer, I should now be capable of deploying my application in a Kubernetes cluster in the cloud. I should also be able to work a data pipeline either for my own app or to communicate with the rest of the business domain that I'm building the application for. Now, where is GenAI in all of that? GenAI initially was in the realm of data. The data team were receiving all that data. They were collecting it, treating it, trying to train ML models out of that data. And it really stayed in that realm. They had their tool. They did their job. And if we're lucky, they were exposing some sort of endpoint for me to use and calculate some scoring. But before that, AI and even the days before AI, it was just for analytics. Application would pour their data into some sort of warehouse. There would be some dashboard connected to it, and some business analysts trying to make sense out of it. And this is where you get the click views, tableaus, SAS, and all the business analysts trying to use this and make SQL queries, trying to find business value out of it. Then we realized that we can do all that data crunching number could be done by a machines, and some product implemented those, and now we get into that batch AI, auto ML, auto regressions, those type of things done by the machine. The third step is having that available within applications. So like I said, now it's because of all the training that has been done in the batch AI phase, we can now use it and calculate a score, a prediction score, directly within that, through that phase. So an application can call an endpoint, get a score, a prediction score of, I don't know, the incident rate, for instance, that you as a person might be subject if you try to contract with an insurance. And finally, since 2023, there's the Gen AI phase, and now we expect much more than just calculating something. We expect the application to be able to communicate with its user. That AI game is a game of responsibility, and if you remember the three colors, blue, green, and yellow, infrastructure is everywhere and touches everybody. But what is in the realm of the data team and what is in the realm of the application team? Is it something where all the data preparation model training is done by the data engineering team and the rest is done by the application teams? Or is it something more where the data team takes a lot more work, or is it something where it's in between and the responsibilities are shared? The truth is, it will depend from company to company and probably from business domain to business domain. But as application developers, you need to be able to touch a little bit of those. So your tech stack and the products that you now need to train on are getting a little bit more bigger. And we get fatigued by all these new tools that we need to learn. But it's part of the job. So there are some things that we need to unlearn and stop using, and we need to let go of those, and there are new tools that we need to get our hands on. So here's an example of a retrieval augmented generation type of application. Typically upload a PDF and do some AI search and questions around that PDF. You see the stack has been evolving where we still have databases in the vector store layer, and that vector stores can come in multiple flavors. Everybody now offers vector stores, whether it's Postgres with pgvector, Elasticsearch has had it for quite some time, MongoDB has it with MongoDB Atlas, and all cloud providers also offer it. So the question now becomes, which one should you use? Should you go for the best of breed and go for a Pinecone DB because that's all they do is vector? Or should you go with Postgres because that's what you've been doing for all your life as a developer? And the answer to that is twofold. First of all, going for the best of breed is rarely the best decision, especially if you're early on in your project. So you start with what you're most comfortable with. It can be Postgres with pgvector, but Postgres will come with the richness of having all your data inside the same table, whether it's the structured data plus the vectors. But you will reach the scalability limit of Postgres, which is vertical scalability that I've talked about, throwing more CPU at your problem. It might work for some applications. For some other, you will need some more scalability, or to separate the scalability between your search engine and your database queries. In those cases, now you need a specific database for that. MongoDB will come with the world in between, where you have the benefit of Postgres of having all your structured data and your vectors within the same store. But you also have the capacity of scaling the vector store and the search engine independently. So in the end, it's a matter of select the tool that you're most comfortable with, and then iterate based on what is the problem that you have. And you see that besides that, you have a complete stack of new tools, whether it's for the UI front-end part, or it's the model inferring, model generating, fine-tuning, that will involve some new tools and new products. And finally, the whole ecosystem AI stack will be much broader than just the technology component that you will be using. There will be elements to help you with your ML model, training that model, storing that model. Then there will be elements to use that ML model and make that inference. There will be the frameworks, LangChain, Llama Index, so how you connect your code base to those AI tools. And finally, the big guys of AI will be the cloud provider and model hosting providers. All of that, of course, the people that will be using that, which are you guys, developers, that will be the main elements in building these applications. So that's all for my presentation. Thank you so much for attending. And now is the time for questions.
Let me take the microphone and read questions. Let's start with the questions that we have so far. Meanwhile, you have time still to ask questions because we have like about 20 minutes. So the first one is, like, it is as it is. I'm just reading. I watched recently a presentation about legacy systems and why we need them. Different POs. Sometimes doesn't matter, you have some price and provide more power. 20, 30 years, spread counts the costs. What do you think? What do you think?
Different POVs, okay, sometimes it doesn't matter.
If you think so.
I don't understand the question. What's that 20, 30 year spread counts the cost?
So the author can update the question meanwhile, maybe add some like details, what you would like to ask, and we will go to the next one. So what exactly means vector store?
Good question. So what is a vector store? Data as we store in your database most of the time is a key in value, or you have the columns in a, let's say, a customer table, first name, last name, etc. This is structured data. If you need to store unstructured data and try to make sense out of it, not just store a file, but if you want to be able to store images and be able to search images of cats out of all those images, this is where you need vectors. So the vectors will be created through transformers, which are ML models that transforms a file, so the buffer, into an array of floats, basically. And that array of floats is stored in a vector store. Your search query then will come, so I will type, give me image of Persian cats. That text will be also transformed from natural text to vectors, and those vectors will be then searched against the other vectors that I already have in the database. So basically, instead of searching text against text, I'm searching for numbers against numbers, which you can think of vectors as GPS coordinates for data. All the magic lives in the ML model that transforms a file, audio file, video file, text into numbers. Exactly. It transforms what it sees in the pictures, basically the pixels, and transform that into GPS coordinates.
Thank you. So if we want to use objects from MongoDB for analytics, example like consumer data with Tableau, do we need to ingest it into a relational database?
So it depends on what type of analytics you try to do. If it's there to support your application, for instance, you're building a game and you need a leaderboard of your players in real time. This you will do directly your analytics query in MongoDB because you need a very fast result, so you'll do it there. However, if you're trying to do a deeper analytics with a lot more data that might come from your MongoDB data, but also from elsewhere, then you offload that not to a relational database, but to a data warehouse. And this is where you'll connect and do all your data analytics job. Yeah, so with Streamlit, basically it offers you a UI, so you can use Python script and then connect that to MongoDB. So Streamlit is offering the UI part. A MongoDB with Snowflake, you would have... So I haven't used it, so I wouldn't be able to know for sure if it's Streamlit to Mongo. I believe it's going to go through Python.
So thank you. The next one is where can we find some technical solution example with MongoDB?
So on MongoDB's website, we have a section with use cases and how our customers have been using it. And we've had use cases in all industries, whether it's gaming, retail, banking, automobile manufacturing, so a lot of cool examples. For instance, airlines that have been using MongoDB for offline monitoring of the airplane, and whenever the plane touches the ground, then all those data are processed, analyzed, and if there's a maintenance that's supposed to be done on the aircraft, it could be scheduled for the next airport where the aircraft will be landing in 8 hours. So that's a cool example, for instance.
What is the usual use of vector store in real applications?
So usually in application, so the classic example is the RAG example, so retrieval augmented generation. Typically, you upload your own proprietary data, for instance, PDFs, those type of things, and then there's an input that you can ask questions around it. The idea is that you kind of have the ChatGPT experience, but without going to search for external knowledge, but only your private knowledge. So companies like this type of tools because it allows all their employees to look through their documentation, to ask questions around some specific business processes, stuff that is private, and this could be done through vector stores.
Thank you. How do you transform database JSON object to Java object in the most efficient way?
So for that, we have the Java driver. That allows you to communicate with MongoDB. The Java driver will get you back your data in format of document/bson, and then you can instantiate a new class, a new Java class, using the data coming from JSON, from that bson document.
How MongoDB compares to InfluxDB as time-based series database? What is different, better in MongoDB?
So I don't have the answer in terms of performance-wise. Everybody will claim different things around performance, and I usually don't get into that question. The idea behind MongoDB doing time series is to offer you a way to have your main database with MongoDB be capable of handling time series type of data. Instead of going to have to go get an InfluxDB right from the get-go because you know you have some time series data. So the idea is have one data platform that allows you to do 80% of your features, and only if you reach the limit, either it's performance that you don't like, or if some features are missing, those type of things, you go get the niche database. And most of the time for time series, we work pretty well. And this feature have been created because customers have been tweaking MongoDB and their usage of MongoDB to fit their time series data within MongoDB. So we optimized that. Most of the time, it's mostly graph databases and graph use cases where they start with MongoDB, reach a limit, and then go get a specific graph database.
Thank you for your questions. Thank you for your answers. Thank you for your presentation. Oh, we have another question, sorry. So why there was no exiting example presented today? So
by exiting you mean?
Okay, so yeah.
What?
So that's why. So something excited.
Oh, exciting. Yeah, good question. I'll prepare that for next year.
So, by the way, about the next year, we are really inspire you to leave a feedback. The form will be opened in the second half of the day. So, last year we were asked why there are no cakes, and this year you see that we have got cakes. That's why, please, we are very careful and precise about your feedbacks. That's why we will be really happy to hear everything about exciting examples, cakes, disclaimer, whatever, what you liked, what would you like to add for the next year, how it's relevant, the information. I also kindly ask you to leave your feedback when you are leaving the room. And we are waiting for you for the next presentation at 11:20. So please return back, and for now, thank you very much. Thank you very much, Riot, for visiting us. Thank you.
Thank you.